So welcome everybody. This is the, I think the last session that's standing between you and the floating lights later today. My name is Paul Stubbs. I'm a program manager at Microsoft. I worked at Microsoft a long time. Been working recently on, AI and Microsoft AI, and recently on starting autonomous systems. So if you think about autonomous systems, it's the way that we move mechanical things, and there are really two parts of that. There's the sort of the intelligence or the brains of that, and that we have this thing we call Project Bonsai, which is around reinforcement learning and teaching AI models how to learn. But the way that you teach autonomy is through experience, and the way that you gain experience is by doing. And the way that you do things safely is in simulation, and that's really what AirSim is all about. It's that sort of that second leg to building an autonomous thing. And so with AirSim, we are able to create these simulated environments and simulate your aircraft and simulate the sensors and the physics and other elements to flying missions safely, so that you can run these, what-if scenarios over and over again through things like domain randomizations. Like, what if it's raining? What if it's snowing? What if a cat crosses in front of my drone? Or, whatever you want to do. Today, AirSim is mainly focused on wings, but you can do wheels as well. So you could do cars and other things, but that's not really the primary focus of where AirSim is today. But we support both, and there's nothing in the platform that prohibits you from doing either one of those kind of things. So today what we're going to talk about is, in particular, PX4. AirSim supports a bunch of different controllers. We support PX4 and obviously Autopilot because we support Mavlink, and then we support we have a simple Python API that you can control your scenarios with if you want to use that as a controller. And so you can use whatever you want to, and you can roll your own. But today I'll also show you, I'll try to go through actually and run this code from scratch, just spinning everything up. And so we'll see what happens. We're going to run PX4 on WSL. So it's sort of kind of a bunch of bad things could happen at any one time, and so it's going to be exciting. But we think about these autonomous systems, right, really contain these three elements: ability to act, sense, and plan, right? And so this loop of perceiving the world by sensors, then making some sort of decision about how you are going to respond, and then act accordingly, and then proceed, right? And you can imagine this happens in a simulation as fast as you can do it, right? We call that the clock, the ticks, the game loop, right, if you will. And this loop is really at the heart of when we think about how we make things autonomous. This is how we think about doing all of those things. And in AirSim, we're able to do those by simulating the sensors and simulating the environments and simulating the aircraft, and then using AI models or using your code to plan a course of action, whether it's what am I going to do in the next second, or longer term course of action, like how do I get across the farm to do the inspection sort of scenario. So one of the things we try to do, and it's sort of classic Microsoft, is we really try to lower the barrier of entry, right? So that normal people, if you will, can figure out how to simulate their aircraft, how to generate synthetic data such that they can train their perception models, how to fly the aircraft, right? And so we try to lower that barrier so that you don't need to be a rocket surgeon in order to figure all of this out. And that then brings on more diverse sets of skills and people, whether it's designers designing the environments, or 3D modelers modeling the aircraft or the objects in your environment, or people running the physics, or AI scientists that are building the AI models. All of those people and those roles are able to participate in the environment. And so you can see AirSim today if you go out to aka.ms/AirSim. We have all the documentation out there. You can download the binaries and run these scenarios on there if you want to. Now, today, AirSim is implemented as a plugin to Unreal Engine 427 and Unity. And so, you know, you think about like, okay, what can you do with AirSim? Like whatever you can do in Unreal Engine or Unity is the starting point for what you want to be able to do in Unreal, right? We add the simulation layer, the sensor models, the vehicle models, and the physics interactions on top of that basic environment. And so if you want to just go out, like I have here in the scene, this is in the neighborhood environment, so you can just download this, the binaries are out there, and then you can run your scenarios using the neighborhood environment, or we have a city environment, and there's a number of them out there, like the mountains one, like you saw in the intro slide at the beginning. Then we can turn on in the simulation a number of views on the various sensors. So you can see the segmentation model, the RGB model, and the different shading models that are coming out of the RGB cameras that are attached to the drone. And all of that information is set up in your configuration file about what your drone looks like, what are the physics, what layout is it, what's the control system, what cameras and sensors it has on it. All of that is defined in the model. How many people have seen AirSim and have used it? Okay. So you all know this in this slide, in this room here, but we think about, you know, the different elements of the way that the pieces that drone code provides us, right? The platform of PX4. We get the flight controller, we get the ground control station, and then we have the communication protocol. And the way that we plug those in AirSim, in this case, this diagram comes from the PX4 documentation. You can see that you have PX4 as your flight control here, and then you have your ground station, which is Q ground control in this case. In the offboard computer in the demo, one of the demos I'm going to show you, I thought it was interesting this morning that, you know, we're talking about the importance of having that companion computer, right? That companion computer, in this case, is represented by ROS2 in the demo that I have. And then the simulation is AirSim in the bottom, and we plug into AirSim can provide all of that GPS, IMU, all that physics information, provides that to the flight controller, in this case PX4, to then do things with the ROS computer on the top to make decisions about what to do. And so what this looks like in a more physical sense is that we have our ground station running on some computer at the bottom that's talking to the hardware, in this case the Pixhawk in this example, running on, that's running the flight control software. And then we want to talk to the companion computer, right? Because the companion computer is deciding what the mission is and what to do. And when the flight computer, the flight controller sees a tree in the road or in the sky, it tells or sends that information to the companion computer, and the companion computer then does its detect and avoid or makes a decision about what to do. It makes inferences about how to see that, and it does that on the AI controller. Now, I've been using this architecture probably for a couple years now, just as ROS2 comes out. We also have a ROS team at Microsoft. There's a ROS for Windows team, which we also do ROS1 for Windows and ROS2. And those are, they're not ports of ROS. How many people are familiar with ROS? So they're not ports of ROS, right? If you use ROS on Linux, the ROS for Windows are similar, but they've been rewritten where it makes sense. There are certain concepts in ROS that are Linux-based that just don't exist in Windows. And so the equivalent concepts have been rewritten from the ground up to be the Windows equivalent of those. So it's not like just running the Linux version of ROS on some emulator in this case. But in this scenario, I'm running the Jetson TX2 as this companion computer. And so we're running, in this case, the Linux version of ROS 2 here. And then you could also run ROS on the ground controller so that those two would communicate together. So this is sort of the pattern that I started with to build this. Now, ROS 2 a few years ago was new, and what was interesting about ROS 2 compared to using ROS, which was much more prevalent back then, was that ROS basically ripped out all of the sort of messaging framework of ROS and re-implemented it using standard DDS. And so that was really cool because PX4 did DDS, and so it really made it, well, relatively easy. And I mean, I don't know if anything's easy in the ROS world, but relatively easy just to talk back and forth between the companion computer and PX4 and pass messages and get messages that way. And AirSim also supports ROS, right? As you run your scenarios, we're publishing topics, and so you can subscribe to those topics and get messages from the various sensors and so on here. So, and again, these come right straight from the PX4 documentation, but this is the idea that, you know, why ROS 2 makes much more sense than using ROS. I mean, because otherwise you'd be using a bridge and it's messy. So the end result is that I built this computer for this demo. I call it the yellow submarine. It's all yellow and has yellow LEDs. And this one was a couple of years ago. So this was a NVIDIA 2080 Ti card running this demo. This one here, does anybody know what drone this is? No? He's actually sitting out in the desk out there. This is a Uvify Draco R drone. So these are pretty cool. So these are, you know, fun. It's all composite. It's got the TX2 built right into it. So it makes it really nice to build these drones. So this is the one I did. Now what I did in this case for this demo, you can see it sitting on a table. This was the Seattle Convention Center before the pandemic that I was doing this demo. But what I would do is I'd plug the drone into the computer, run the Jetson, and run the control board on there doing hardware in the loop. So the demo was running on AirSim, but I was using the compute on the actual drone without actually spinning up the props for this one. Okay, so this one, this was a little bit, I mean, there was a lot to this demo, right? Because basically everything you saw on that architecture slide, we implemented here. And we implemented everything in this case as Docker containers. And so you'll see as I run the demo that we'll start spinning up the Docker containers. But what happens is we're reading the sensors in ROS that are being published by AirSim and by PX4. And then we fly the neighborhood using Q ground control to map out a path around the neighborhood. And then we've created a 2D projection of that map as a web page. And so we subscribe to the messages coming off from the drone to map out locations on the map. And then what we're doing is we just use this off-the-shelf YOLO model to detect cars. So the drone basically flies around the neighborhood looking for cars. And then when it finds them, it maps them and logs them and draws a spot on the map for them. So that was the demo. And so you'll see this as it's running here. So in the beginning, we just use PowerShell. We spin up all the Docker containers. So this was really good. I think I need to rewrite this demo now. And so you'll see when I do the live demo after this video, you know, I'm doing it in WSL2. Now, this was all done in Docker. And in fact, the Docker container is running NuttX, and we're running PX4 natively in a NuttX environment on here. So that's really kind of slick. So you can see once we get it up, we're connecting to the simulator once we start that up. So there's Q ground control starting in the background. This is AirSim. So now AirSim is started. You can see we're connected down here in PX4, so that's connected. And then Q ground controls over here that we can ready to start the mission. So this is these are the messages that are coming out. See, these are the messages as we're reading the frames from the camera. And so these frames from the camera are coming out of the sensors that we're seeing here. And we're passing those and inferencing those on the AI models. Now, one thing you see here is that in AirSim, you can load what we call geotypical environments, so like a neighborhood or a city or a beach or a mountain. And that's what you see here. So this is a geotypical environment of a neighborhood, but Q Ground Control wants to load an actual map, right, from Bing or Google or wherever. And so it has a map of just whatever lat and long that I passed it in from the simulation. So it doesn't match. So that's why you see this sort of weird, like just square in space. That's the Redmond campus. And what happens here is that we can also load geo-specific environments. Like you could go get the cesium plugin and load an actual geo-specific environment with the actual neighborhood or city, and then those would match up. And you may see a little bit of that in the demo I show later. But you can see they're all synced. So we're reading the frames from the camera. You can see what the drone sees. It's flying along. You can see the 2D projection that we're reading where the location is, putting it on the website, which is that one there. And then you can see that we're synced up with Q Ground Control. And then Q Ground Control is running the mission, right? So the Q Ground Control is going from waypoint to waypoint. And you see it passed a car, but it didn't see it, right? And there's some cars here that are in the dark and didn't see it. So this is where you would run your training and say, hey, why didn't the drone see this obstacle and what happened? When it gets to one here, you can see that it sees it and it'll put it on the map and we can see the location, you know, of that image that was captured for that information. So this is sort of, it's kind of a complex demo, but this is sort of the end-to-end scenario of everything kind of running together and how it fits end-to-end, and then it goes all the way through to the end. Questions on that before we move on? It's just going to go around the neighborhood and then land. Yep.
So where's the AI? How does it fit into?
Yeah, so in this demo, we're reading the images out of the camera sensor and passing them to the YOLO model. So the YOLO model is just, you just go download it off the internet, it's already pre-built. But these images are also, you can just set the flag in AirSim and you could capture those on disk. And so the idea would be you capture all of this training data and then you take it up to Azure Machine Learning or some other service and train a model that you would then bring that model back into here and then run it again with your model. So what I would do is as I missed that car, I'd go, why did it miss the car? Let's go add some images for that so the next time I run the model, it'll see those things that it missed.
Are you using the output of this, the training model in real world app or
Sorry, say that again?
like are you using this as synthetic data and then using that in the real world afterwards as a training model?
Yeah, so the idea would be that you generate synthetic data that you then train a model on and then use that model to rerun your simulation again to validate it and then run that in hardware in a loop like you saw in that picture to then see what the performance is like, right? Because I could get a fancy computer that's not going to run anything like it's going to run on the drone. So then you get the model working right on the drone for that performance, and then you deploy to the real you know thing. That's the workflow, right? A lot of times people skip this step and just go out in the field and run the drone and crash the drone and run it again and like that. The idea here is that you can do these. And so we do a lot of, like the drones we're working with, like we do a lot of work with Bell. So the Bell APT-70 is the autonomous pod transport. So it carries up to 70 pounds. So these are like, you know, Humvee size drones that carry supplies in the field or, you know, delivery and stuff. So typically, you know, the things we're working on are much larger than like, you know, the drone you saw in the picture. But that's the idea. All right, we have a few minutes left. I'm going to try to see if we can do this live. See if it works. You know, the key to giving a good demo is when it works, you don't act surprised. Okay, so the first thing that we want to do is we're going to run this in WSL, and you can see we have the IP address of the WSL container here, and I'm running Ubuntu on here to host PX4. And so PX4 is in essence running in this virtual machine in WSL. And so it's going to communicate back to AirSim and Q ground control. And so this is kind of it needs to be fixed, but this is the experience so far, so I'll walk you through this. So that's what we need. So we need this IP address, and we need to change it in a few locations. One of the first things we need to do is we need to you need to open the firewall so that that container can reach back across to your Windows machine. And so what I've done in here is I've set up a couple of rules to allow the communication to go inbound. So a 4560 on the TCP/IP, and then basically 14, 550, 540 on the UDP to come back in. The other trick to this, which is challenging, is see all these red things, the red squares? Those are blocks in firewall. And so when you install Unreal Engine, I don't know who does it, but I assume Unreal Engine is installing all sorts of any port blocks in, as a rule, in the firewall. And so even though I open 4560, Unreal Engine says if you run Unreal Editor, block any IP addresses coming to this instance of the editor. So that rule supersedes. So what you need to do, you can see these are off. So I just went through all the Unreal Editor rules and disabled them so they don't block the port. So that's just one thing to keep in mind. So next thing. So now what we need to do is let's fix up PX4. So this here is the config file for AirSim. This is located in your documents AirSim folder. And what we need to do, we need to use the vehicle type PX4, and we need to say use TCP/IP, and then we need the IP address of what this host is going to be, right? So what we need to do is we need this IP address here. So 172.21. So let's put that in here. Okay, so that's good. So now AirSim now knows what IP it should be looking at. And the next thing we need to do is we need to fix up PX4. Now, all I did was I downloaded through Git PX4. And then what we need to do is there's a couple things we need to fix up. So first, every time that you reboot your computer, your IP address changes and you have to go through this step. So this is kind of the unfortunate part. So first thing, let's first clean up the old build, which has the old version of PX4 in there, so we can get rid of the old IP address. So this is going to go through and basically clean out all the binaries that we've had in there before. Okay. The next thing we need to do is now we need to take that IP address. So let's, and we need to set the variable for this. So this is here. So this is our new IP address, right? 128.1. So now we have that set, and we can check it hopefully here to make sure to validate. This is the sanity check that you'll do because you'll get IP addresses wrong. The next thing is, this is where it's kind of gets, we actually have to edit the source code of PX4 to fix the IP address. And the IP address has this set here where it's going to try to reach out and look for that that IP address. So we have to change this here, and this is what causes us to have to recompile. So let's see, 21.128. Okay, so we just had to set the IP address. Now we just need to build it. Let's see where we are here. And then once this builds, we'll have PX4 running on WSL2, which is good. While that's building, let's go look at AirSim. So in AirSim, when you download it, there's a sample environment called blocks, which is just kind of, if you don't have a really powerful machine, it's good because it's just simple with a few blocks, but it allows you to do everything. This one is also on Unreal Engine 4.2.7. So you can run that. Okay, so PX4, so that's a good sign. PX4 started. It's waiting for somebody to talk to it on 4560. And so here we have AirSim loaded onto that port. And so now we can start the simulation here. And hopefully, if things work right, we'll connect. We'll see how it goes. There, so we connected, so now you saw PX4 in the background going. So now we're talking from PX4 across the firewall to Unreal Engine, which is AirSim, running the simulation. We got a good GPS lock and we're good. So now we should be able to open Q ground control. And then I had a little simple triangle that I drew, so we should be able to just take off. I think you're not going to take off today. No. Let's do a new. Let's take off. No. So close. No. Yay. So, and the reason was because, like, when I stopped Q ground control the first time, it thought it had uploaded the mission and it wasn't. And anyway, so welcome to my world. So this is, so now you can see PX4 is running in the background. We're running AirSim here, which is the simulation. And then Q ground control's doing its thing, flying the flight plan here all off of WSL. Ta-da. Good? Yes? Okay. And we're on time, and it's the perfect temperature to go watch drones. So that's all I had for today. So again, if you want to try this yourself, go to ak.ms/as. And you can try it, or you can go to ak.ms/AirSim and go to AirSim directly, or look at all of the autonomous system stuff as well. And that, if anybody has any questions, I'll take questions. If not, I'll be up here afterwards. And thank you.